Hello students, we have to solve to this problem, and this is problem for probability density function and joint probability density function. Here we will find joint. There are three parts of this problem that we need to find. First, the joint distribution function of x and y. Second thing, the marginal density function of y. And third point is that probability of x less than equal to 1 by 4 given us, this is the conditional probability. What we have given us, the probability of y less than equal to 1 and greater than 1 by 2, right? So we will solve this problem here. Now first of all, let me raise this one. Yes, no, it's okay. So now first solution here. Let me increase the volume first so that you can understand better what I'm going to tell you. This is 70. Now it's okay. So now solution here. First part, the joint distribution function of x and y. So we will denote here the joint probability density, sorry, joint distribution function of x and y, capital F suffix s y, capital X comma y. This is the notation. And my dear students, there is a relation. What is relation here? This is what this is. I can say this is f of x y and small x comma y, right? And this is the relation del square of del square x and del y. We will use this relation, right, to solve this problem, right? What here we have to find? In first problem we have to join distribution function of x and y. So this is what we have to find, capital F x comma y, right? So now how will find it? Let me tell you in next slide. Yes, so I will going to write here capital F x y equal to, now this will be the integration, double integration dx dy, right? And density function what, at x y, right? Now here the limits given us here, x greater than 0, less than or equal to y less than 1. Dear students, go to the formula of this one, the relation between PDF probability density function and joint distribution function, right? Here we have to fix this x upper limit will be in case of x, that is x, upper limit of y in case of y. Here lower limit will vary. Here lower limit will vary, and in this problem the lower limit is 0. But in the formula you have to go through the books. They are giving you minus infinite because they are taking the minus infinite to x. But here according to problem we have 0 to x. Now, so here what we have to do? Now see, this is 0 to x, limit of x, this is 0 to y. So we have to just going to integrate with respect to y. So we will write here at outside at x, and this is y, and dy, and there x, right? Now this is what here, integration 0 to x, this is at x, y square upon 2, y square upon 2, a limit here 0 to 5 dx. So finally we have here what, 8 4 y square integration 0 to x and of x dx. This is again becomes what here, x square by 2, x square by 2. So 4 y square, right, x square by 2, and the limit is 0 to x. right? So we can write here 2x square y square. This is the joint distribution function. Now if you want to check whether this is correct or incorrect, so you can use the relation here. What? F of x comma y means joint density function is equal to del square f of del x of y. Right? So this is capital F. Just differentiate two times. First with respect to x, with respect to y, you get at xy. Right? So now this is verified. Now this first part is solved. First part is clear. Now go to the second part. Second part, we have to find the marginal density function of y. Marginal density function of y. So we will write here marginal density function of y. Wait. Right here. Yes. So you can write here capital of y equal to what? Integration dx probability density function, that is at xy. We have to put the limit of x, that is what? 0 to 1. That is 0 to 1. So give together what? Y 8y integration 0 to 1 ex dx x dx. So we have 8y to x square by 2, x square by 2, limit 0 to 1. So we have here how much? 4y, right? 1 minus 0. So finally we have 4y. This is the marginal density function of y. Now go let's get third part. In third part we have to find probability of what? X less than equal to 1 by 4 given us y less than, let me see the problem that we have. Yes, y less than 1 and greater than 1 by 2. This is right. Now so for that we have to find the probability of x less than equal to 1 by 4. How will you find? Listen. Probability of x 1 by 4 equal to, we have to find here double integration. Here you have to find the limit here. You see, s greater than 0, less than equal to y less than 1. Right? So here PDF at x y dx dy. Now here upper limit of x is equal to 1 upon 4 and lower limit of x is 0. What about y? Lower limit of y is what here? That is x. Upper limit, that is 1. That is 1. Okay. Now so you have to first integration 0 to 1 upon 4. Just integrate with respect to y first. So we are writing here at x, then within square bracket integration x to 1 y dy and dx. Right? So this is what integration 0 to 1 upon 4 into at x. This is what? Y square upon 2. So I am writing here 2 here. Y square limit here x to 1 dx. Right? So we become of 4 integration 0 to 1 upon 4. Right? And this is x. We have 1 minus x square dx. So 4. Now so I am 0 to 1 upon 4. Just you can write here x minus x cube dx, x minus cube dx. Now 4 integration 0 to, sorry, again I am going to solve note here. Yes, this is 0 to, now just integrated. X means x square upon 2 minus x cube means x cube raised to power 4 upon 4, right? Limit 0 to 1 upon 4. Now you can take common here 4. You are taking 4, you can write here 2x square minus x raised to power 4, right? Limit 0 to 1 upon 4. So you can write here 2 into 1 upon 4, that is 1 upon 16 minus 1 upon 4 into 1 upon 4 into 1 upon 4 into 1 upon 4, we get to 56, right? So you can write here just 32 minus 1, right? 32 minus 1 upon 256, we have 31 upon 256, right? Now in next slide, 31 upon 256. Now we have to find the here probability of what? Y less than 1 greater than 1 upon 2. This is yes. So how will you find that? Then again double integration. For PDF here 8xy dx dy. Now limit c s greater than 0 less than equal to y less than 1. Now according to problem we have y fixed. That y, what is x here? In case of x, the lower limit is 0, upper limit is y, and the limit of y, lower limit is what? Here 1 upon 2, upper limit is 1, right? So now integration 1 upon 2, that is 1. Okay, these are the y. So we write here at y. Now I'm going to integrate 0 to y ax dx, that is dy, right? Because we are going to integrate with respect to x, we have to put the value of x, right? So this is x square upon, now I can write here, this is 4 integration 1 upon 2, so 1 y, right? This is x square by 2, this is 2 4 ja 8, right? This is x square, limit here 0 to y and dy, right? X square by 2, that is. Now you can write here 4 integration 1 upon 2 to 1, this is y. You can write here y square minus 0, that is dy, right? So this become 4 integration 1 upon 2 to 1, this is y cube dy, right? Y cube dy. So you can write 4 upon 4, right? Y raised to power 4 and limit 1 upon 2, 1, right? So this 4 cancel. You have here 1 minus 1 by 2 raised to power 4. So you can write here 1 minus 1 upon 8, sorry, 1 upon 16. So 1 minus 1 upon 16. Finally we have 16 minus 1, that is 15 upon 16. Now, so the probability of what here? X, capital X less than equal to 1 upon 4, given us probability of y less than 1 greater than 1 upon 2 is equal to what? Probability of x less than equal to 1 upon 4 upon probability of y less than 1, yes, greater than 1 upon 2, right? You can just look out this 31 upon 256 upon 15 upon 16 you can do, right? So this become 16 into 31 upon 256 into 15. 16 1 is 16, 16 is this. You can get a 31 and 15 sister 90, 9, 5 15 is 15, 59 to 40. So this 31 upon 240, this is the answer. I hope so. That is the problem. We enjoyed, right? Okay. Thank you all.